Alright, so we just figured out how to determine the number of valence electrons in a given element and then what ion it's going to form. So now I'm going to teach you how to write the actual formula using this neat method called the crisscross method. And this is thinking about what ions these atoms are going to form and what ratio they need to be bonded together by to give the whole entire ionic compound a neutral charge, right? So we have a couple examples. Potassium and iodine are each going to form a positive +1 cation and a -1 anion, right? So if these charges cancel out, you don't have any subscripts to put in. It's just potassium iodide, you type in Ki, or you write Ki next to each other, and that's the ionic compound form. Same for calcium and oxygen. +2, -2, these cancel out, so it's going to be calcium oxide, like that. Down here, let's go through an example like this. What if we have a potassium +1 cation, and then an oxygen -2 anion? These two don't cancel out, so the way that you need to write this is you're going to crisscross the charges, and the superscript, the charge, becomes the subscript for the other element. That's kind of confusing, so let me explain, right? So the ion formed is going to be potassium to oxygen. So 2 potassiums and 1 oxygen. The reason that is because to cancel out a -2 charge, you need 2 plus charges. That's why there have to be 2 potassiums and then just 1 oxygen. You have +1, +1, -2. That's why it's neutral. So I'm going to go through a couple of practices to show you my thinking. So we have boron and phosphorus. So boron, we need to figure out the ions it's going to make. So let's figure that out first. So boron's over here. We know that it has 3 valence electrons. So it's easier to give up 3 electrons than gain 5, right? So we're giving up 3 negative charges. So we're going to form a positive 3 plus cation. So boron 3 plus. And then we're going to have phosphorus, right? So phosphorus is right here. It has 5 valence electrons, so it wants to take in 3 electrons. It's easier to take in 3. So we're going to have phosphorus, then we're going to have a 3 minus because it's taking in 3 electrons. So these cancel out, right? So that means we can just type, boron, phosphorus. Easy as that. Let's do another example. Sodium iodine. So sodium is going to form a +1 cation. 1 plus. And then iodine is going to form a 1 minus cation. These also cancel out. So our final formula is going to be sodium iodine. Now we have an interesting example. Aluminum, we find that is going to form, it has 3 valence electrons, so it wants to get rid of them. So aluminum is going to form a 3 plus cation, and then chlorine is going to form a 1 minus anion because it's over here. It has 7 valence electrons, it wants to take in 1. So now we have to do the crisscross, right? So 3 is going to be after the Cl, and there's going to be, we don't put 1 as a subscript. So our whole formula is going to be Al, Cl, and then subscript 3. See how we're doing the crisscross? The 3 comes down here behind Cl, and then the 1, we don't write 1 in an ionic compound chemical formula. So AlCl3. And then that 3 means that you have 3 negative charges in the 3 negative chlorines, balancing out the 3 positive charges from that 1 aluminum atom. So that's how you use the crisscross method. So give that a try for each of the problems and email me if you have any questions.